Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.5, Problem 9. This is Section 15.5, Problem 9. It says find the area between the function f of x equals x squared shown in red and g of x equals x to the fourth power shown in blue. So just to be very clear, the red is the x squared. The blue is the x to the fourth power. So now the area between them is split into two separate parts. So the right way to do this is really two separate integrals. So find one, and you can find them in either order. Find one of them first, keep track of the answer. Find the other one, keep track of the answer, and then combine those two answers. So to find any, let's just go from left to right the way we read printed words. We'll find this first, see what it is, and then find that one, combine the two. To find any area trap between two graphs, you do a definite integral, the integral of the top minus the bottom. And I'll include a dx with that. So the top or upper function for either portion, but again, I'll just focus on the left half, is x squared minus the bottom, which is x to the fourth. Don't forget, it has to be minus. I'll put the x squared minus x to the fourth in parentheses, put a dx on the end. And before I do the definite integral, I need to know my limits of integration. So for the left-hand piece, there are 2 points of intersection. Those 2 points will provide me with my two limits of integration. The leftmost point of intersection is, you can pretty much read it off the graph, it's back 1, up 1, negative 1, comma 1. The other point where they intersect is 0, 0. So it's the x coordinates of those points that are my limits of integration. I have a negative 1 and a 0. You want the larger value on top. 0 is actually larger than negative 1. So 0 is my upper limit of integration, minus 1 is my lower limit of integration. So I'll go ahead and do the 4 steps that would give me the solution to that definite integral and keep track of the answer. So first, step 1, let me solve the integral. The integral of x to the second is 1/3 x to the third. Then minus the x to the fourth will give me 1/5 x to the fifth. And I'll put a long vertical line to the right of that, put my limits of integration next to the long vertical line, and step 1 is complete. I solved the integral. Next step, put in the upper limit of integration, which is pretty easy, it's 0. So 1/3 x cubed will become 1/3 0 cubed, minus 1/5 x to the fifth will become 1/5 0 to the fifth, which is simply 0. Zeros are nice. Then next I'm going to have negative 1 as my lower limit of integration will go in for x. So 1/3 x cubed will be 1/3 negative 1 cubed, minus 1/5 x to the fifth will be minus 1/5 negative 1 to the fifth. So watch out for the negative. So negative 1 to the third, it's an odd power, so it'll stay negative. It'll be 1/3 times negative 1 minus 1/5 negative 1 to the fifth. Again, a negative exponent will keep the negative. So 1/3 times negative 1 is negative 1/3, but then negative 1/5 times negative 1 is positive 1/5. Now, negative 1/3, positive 1/5, I'm going to need some common denominators. 15 would be good. The negative 1/3 can be written as negative 5/15. That's still a 1/3. And the 1/5 can be written as 3/15. That's still a 1/5. And now, negative 5, positive 3, I'm going to have negative 2/15 from plugging in my lower limit of integration. And now to finish the left portion of this, I'm going to subtract the step 2 result of putting in the 0, which gave me an answer of 0, and the step 3 result from plugging in a negative 1, which gave me a negative 2/15. So let me put it over here. 0 minus a negative 2/15 would be 2 positive 2/15. I'm thinking a step ahead when I say 4. So that area is 2/15, the left portion of the trapped area. Because it's symmetric, I know that the other side is 2/15. So 2/15 and 2/15 is 4/15. Let's say you didn't know that, or you thought that was the case, but you weren't really sure. The right way to do it would be to just find the right-hand half using the same process. I know it's going to come out to 2/15 again because of the symmetry. Pretend you didn't know it, or you thought so, but you weren't sure. You're going to do integral of top minus bottom. It's pretty much the same process with different limits of integration. Put a dx at the end. Now my limits of integration, 0, 0 is still one of them, but the other point where they intersect is positive 1, comma 1. Again, it's the x coordinates I'm interested in. The larger of the two values is positive 1. The smaller is 0. So as I go ahead and fill this in, I have the 1 and the 0. The top function, the red one, is the x squared, minus the bottom function, the blue one, is the x to the 4th. I'll put x squared minus x to the 4th in parentheses, dx on the end. I have my limits of integration. Larger value is the upper limit. Smaller value is the lower limit. So, 4-step process. Step 1, solve the integral. You have 1/3 x to the 3rd minus 1/5 x to the 5th. Again, plus a constant, which I don't need to write because I know it's going to cancel. I'll put my long vertical line with my limits of integration to the right of my answer. So that's the result for step 1. Step 2, plug in the upper limit of integration for x. So I have 1/3 x cubed becomes 1/3 1 cubed, minus 1/5 x to the 5th is 1/5 1 to the 5th. Since there are no negatives here, I can go right to 1/3 minus 1/5. Again, same numbers, same common denominators. The 1/3 will be 5/15, that's a 1/3. The 1/5 will be 3/15, that's a 1/5. 5/15 minus 3/15 is 2/15, which winds up being the answer, but you're supposed to plug in the lower limit of integration, which will give me a 0. So 1/3 x cubed will be 1/3 0 cubed, minus 1/5 x to the 5th is 1/5 0 to the 5th. I have 0 minus 0, which is 0. So finally now 2/15 minus 0, the 4th step. Subtract the step 2 result minus the step 3 result, 2/15 minus 0, which is 2/15, which is what I suspected it would be, again, because it's symmetric. So the right portion is also 2/15. So 2/15 from the left side plus 2 more 15ths from the right side gives me a total amount of volume of 4/15 trapped between the red and the blue graph.